Okay, so for this video, we are going to discuss October-November paper, 2021 paper, and this paper 1-3. Okay, so for this paper, the first question, they give us a graph, and then it is transformed to this equation. All right, so describe fully in the correct order the two transformations that have been combined. Right, so from this equation here, generally you can see that from fx, when you want to change it become this transform equation, the first transformation is actually multiply the negative sign. So when you multiply a negative sign outside the basic and a function, right, outside the fx, it should be a reflection. All right, so you can write as a reflection through the x-axis. It is the up-down reflection. That means that the graph will be reflected through the x-axis. All right, which means the negative value become positive, then the positive y value become negative. All right, so that's the first transformation, and after that followed by a plus 3. Okay, so a plus 3 is actually a translation, so you can write as a translation in y direction by moving the graph up 3 units. Okay, so this is what you have. So please take note that for this transformation, okay, the sequence or order is important. So the first one, the first step to transform the graph is through a reflection, followed by a translation. Okay, so now we come to question number 2. Okay, so for question number 2, they ask us to find the first 3 terms for this particular bracket, right? So first 3 terms. Okay, all right, so maybe I highlight it first. First 3 terms, and then in ascending power of x with this expansion. Okay, so I'm having 1 plus ax power 6. So this one belongs to binomial expansion, right? First 3 terms means that you start from r equals to 0, which means 6c0. The first term, power 6. The second term, power 0. Okay, then 6c1. Okay, 1 power 5. And then the second term, power 1. Followed by the next one, 6c2, 1 power 4. And also ax power 2. Okay, so you can see that there are 3 terms here. First term, second term, and third term. All right, then you straight away press calculator and try to simplify your answer. The final answer for these first 3 terms will be 1 plus 6ax plus 15a square x square. Okay, right, so this is the first 3 terms that we have for this expansion here. And after that, what they want us to do is like in part number B, they want us to, or they give us the coefficient of x squared in this expansion, and it is equals to -3. So again, the keyword here, the important things here will be coefficient of x squared is -3, and we want to find the possible values for the constant a. So please take note that here they actually mention positive values. So that means they might have more than one value for a. Okay, so let's start with the expansion given here, 1 minus 3x, 1 plus ax power 6. Okay, so 1 minus 3 I just copy. 1 plus ax power 6, right? I will substitute the expansion that we get just now in part A. All right, because in part A, the expansion already include the x squared up to and includes the x squared. All right, so I can straight away substitute my expansion in part 1 into this part. And after that, I will try to figure out, all right, what and how will I get x squared. All right, so to get the x squared, what we are going to do is like we are taking the first term, multiply with this one, then you will have an x squared. All right, and after that, for the second term, -3x, you have to multiply something with x also, so that the result or the outcome, you have x squared here. Okay, so from here we'll continue. 1 multiply with 15, a square x square, I will have 15 a square x square. -3x minus this one, I will have -18. All right, so -18 ax squared. And if you try to factorize it out, 15a squared minus 18a, this whole thing, you can factorize out the x squared. All right, and just now they already mentioned the coefficient of x squared. This is the coefficient of x squared. it should be equals to -3. So continue from here, you should try to get the value for a. So 15a squared minus 18a equals to -3. All right, then you can further simplify it. All right, then you can see that you actually get a quadratic equation in terms of a. So you can try to factorize it. All right. Okay, so I'm having a equals to 1 over 5 and also a equals to 1, where we get the values of a. So there are two values for a, okay, for this question. Okay, so now we come to question number 3. For part A, they want us to express this expression into a completing square form, all right, where a and b are constants. All right, so to completing square, generally what we need to do is that we have to factorize the coefficient of y squared first. So I'm having 5 and then y squared minus 6y. And from here, I would like to add the b divided by 2. So b is -6, right? Divided by 2, you're having -3. So plus -3 square minus -3 square to complete the square, all right? Then plus 50. The constant term, I didn't factorize it, all right, because it will not be affected. Okay, so 5, the first three terms, okay, I will compile it become a bracket, which is y minus 3 square, and then minus 9 plus 50. And I try to multiply in the 5 and also the 5 into the bracket so that it will become 5y minus 3 square minus 45 plus 50. And eventually the answer will be this one. Okay. So this is what you have part A, what you have for part A. All right. So from here you can see that if you compare, A will be equals to -3 and B equals to 5. So if you want, you can write it out. A equals to -3 and B actually equals to 5. Okay. All right. Okay, so for me, I will just rewrite it, okay, in the form that they want us to show. Right, then now, the part B, the function f is defined by this function, and they want you to determine whether f is increasing, decreasing function, or neither. Okay, when you want to investigate whether f is increasing, decreasing, or what kind of function, right, we can actually try to investigate through the f prime x. So this is my original function, which is fx. Okay, then we would like to find out the differentiation for this function. So I'm going to find out the f prime x. So when I try to find the f prime x, I'm having 5x power 4, 30x power 2, then plus 50. Okay, and if I try to compare, okay, this is my f prime x. If I try to compare this equation and also the part A equation that we attempt just now, you can see that they are having the same pattern, the same coefficient. 5y squared, I'm having 5x power 4. -30y, I'm having -30x squared. And 50, I'm having 50 as well. All right, so if you compare it directly, you can see that y is actually the x squared in this case. Okay, so that means for this case, right, I can rephrase my answer into a completing square form as well, like what we proved in part 1, what we did in part 1. So I can rewrite it become 5, and y is actually my x squared. Okay, then minus 3, then square plus 5. Okay, so why we want to express it in this completing square form? Okay, it is just to find out and make a conclusion, okay, about the function. So you can see that for anything with the square, like x squared minus 3 square, okay, it tells us that this bracket square is always positive, right? No matter what value you substitute, okay, for the x, Okay, so minus 3. This whole bracket, when we square it, the whole value that we get here for this part should be always positive, right? Okay, so we can write that this is actually always positive. And also, when you're having a positive value, you plus 5. Any positive value plus 5, it is still always positive. It will not become negative. So here, actually, you can see that my f prime x is always positive. Okay, or maybe we can write as greater equals to 0. All right, okay, so f prime x is greater equals to 0. So you can make a conclusion such as the f prime x is always positive. Okay, regardless the value of x. Okay, so this also tells us that actually f is an increasing function. Because when our dy dx is always positive, which means that your function is always going up. All right, so it is an increasing function. All right, so this is how we actually show. We should try to link it with the differentiation f prime x. Okay, so question number 4. All right, so they are mentioned that there's the first term of arithmetic progression. Okay, so first term, arithmetic progression is 84, and also the common difference is -3. So from here, we should know that A is equals to 84, and also the common difference should be -3. So they want us to find the smallest value for n, for which the n term is negative. So n term is negative. If I try to write out in a symbol form, it should be Tn, the n term should be smaller than 0, 0, right? Because it want it to be negative one. So Tn smaller than 0. So what is the formula for Tn? Okay, so for Tn, it should be A plus n minus 1d. A plus n minus 1d, it will be 84 plus n minus 1, and d is -3, which is smaller than 0. All right, so you try to expand everything here. Okay, what do you get is 84 minus 3n plus 3. And from here, you will get 3n. It will be greater than 87. And therefore, n will be greater than 29. So n must be a whole number. Therefore, n greater than 29, the next whole number for n will be 30. So for this example, n is equals to, okay, then now we go to part B. Alright, so for part B, they mentioned that the sum of the first two k terms in this progression is equal to the sum of the first k terms. So they want us to find the value of k. Alright, so from this sentence also, first 2k terms, sum of first 2k term will be s2k, then equals to the sum of the first k terms, so it will be sk. Alright, okay, so now I will want to substitute all the value and also write out the formula for sum to 2k and also the sum of the first k term. Right, so the sum to 2k, it will be 2k divided by 2, which is n over 2 lah. Then 2a will be 2 multiplied with 84, okay, plus n minus 1d. n is 2k for this case, minus 1, d is -3, and it is equals to n over 2. So k over 2, 2a plus n minus 1d. Alright, so this is the formula for S2k, the sum 2k, and also this is the formula for the sum of the first k terms. Okay, then what you need to do now is you try to simplify all the things for both sides. Alright, so for left hand side, I will have this. And then for the right hand side, I will have 168 minus 3k plus 3. Okay, so if you continue to express and simplify everything, right? So you should have 9k equals to 171. And from here, lastly, you will get the k equals to 19. So for this question, the value of k is 19. Okay, so now we discuss question number 5. Okay, so they give us a diagram and then they are saying that the x and y are the point on the line AB such that BX is 9 cm. So BX is 9 cm and also AY is 11 cm. So the arc AB is part of the circle with center X. So you can see that the arc BC center will be the X here. Alright, so generally you should know that this is actually 9 cm, okay, where BX also 9 cm. Alright, where CX is perpendicular to AB. So the arc AC is part of a circle with center Y and the radius is 11. So you are having center Y, radius is 11. Therefore, AY is 11. At the same time, CY is also 11. Okay, so for this one, it will be 11 as well. All right, so from here, they want us to show the angle XYC equals to 0.9582 radian, correct to 4 significant figure. Right, so the angle XYC will be this angle. Okay, so this particular angle, they want us to prove that it is equal to 0.9582. All right, so by using the triangle here, there's a right angle triangle in this diagram, and I would like to use the information from this right angle triangle to get the proven done, right? The proof. Okay, so now let's start. We are having 9, which is the opposite length. We are having 11, which is the hypotenuse length. All right, for the angle XYC. So from here, you can see very clearly that I can write out the sine for the angle XYC will be equals to 9 over 11. All right, so when you take the sine over becomes sine inverse. I think very easily you will able to get the answer, which is 9582 radian. Okay, so the main thing is we are trying to use the triangle to help us. All right, and after that we are going to part number B. So for part number B, they want us to find the perimeter of ABC. Okay, so to find the perimeter of ABC, all right, so generally what we need to do is that we have to try, okay, to find out all the length of the sides. Okay, so first I will have BX. So BX is this length. Okay, then plus I have the length for AY. Okay, so the length for AY will be in green color. And from here, you will realize that there's an overlapping part when you add these two lengths together. So this is the overlapping part in highlight, yellow highlight. So we have to actually minus the overlapping part. So minus the length for XY. Okay, and after that, what we need to do is that we need to add the arc, the length of the arc BC. Okay, so plus arc BC and also plus the arc of AC. Okay, so plus the arc of AC. All right, so generally this is what we need to do lah. Okay, so what is the length for BX? So the length for BX, okay, X is the midpoint, right? Sorry, it's the center of a particular center. A particular circle, right? And BX here is 9 cm, so you can write as 9 plus AY. So AY is 11. Okay, then minus the XY. Okay, so again, to find out the length for XY, you can still use the Pythagoras theorem for this particular triangle here, where we know that this is 11, the hypotenuse, and this is 9. Therefore, the final, okay, the length for the last side here, the third side is actually 11 square, hypotenuse square minus the one of the length, the length of the one of the side square. Okay, so 11 square minus 9 square plus the arc BC. Okay, so the arc of BC should be r theta. The center, the radius is 9, and the angle is this one. Okay, so the angle is this one, which is actually 90 degree lah, pi over 2. Okay, and also plus the arc of AC. So the arc of AC, again, it is actually the arc, which is 11, and then the angle. So the angle that we need to use is this one, the first part answer. Okay, 0.9582. Okay, so once you list out everything in detail, then you try to get the answer. So the answer that I get is actually 38.35326909. And of course, I need to correct it to three significant figure, which will be 38.4. Alright, so this is how we actually get an answer for this perimeter of ABC. Okay, so now we come to question number 6. Alright, okay, so they give us a diagram, and from this diagram, they are telling us that this is actually y equals to fx. Then on the same diagram, they want us to sketch the inverse function. Okay, so when you want to sketch the inverse function, the inverse function and the original function, right, they are having a relationship actually. So for what you learn, you should know that they will reflect each other at the line y equals to x. So just imagine that this is the line y equals to x, and it will be like a mirror, right? It will be like a mirror, okay, of the inverse function graph. So you have to imagine that by using this mirror, okay, so you want to reflect your graph, okay, on this line. All right, okay, so if you reflect it, your inverse function graph will look something like this. Okay, so the green color part, it will be y equals to inverse function. Okay, so this is what we have for part number 1. All right, then now we go to part number 2. Okay, for part B, they are now giving us the function itself and also the domain. So the domain will be from -2 until +2. They want us to find the inverse function. Okay, all right, so now I will do it here. Okay, so usually how I start is that I will let y equals to the original function. Okay, so to get the inverse function, what I need to do is like I have to rephrase my equation until I get x equals to something something y. All right, so to do that, I will slowly group all the things together. So first step, I will square both sides. The next step is I will move the 4 minus x squared to the left hand side, and therefore this is what I get. And now I want to group all the x squared to one side. And after that, I will factorize the x squared. Okay, so for the next step, I will move all the terms which is in y or maybe the number to the right hand side. So if from here you can see very clearly that we are having x equals to something something y already. Okay, and of course for this one I can further simplify, become plus minus 2y on top, then divided by square root 1 plus y squared. Okay, then now I want to decide which is the correct inverse function, because for my answer here, the solution for this step, we are having two answers actually. The first one will be positive 2y over square root. Then another answer will be negative 2y over square root 1 plus y squared. Okay, so how am I going to decide which is the correct function that I should use, okay, or I should select as the final answer? Okay, so previously when we learned in quadratic expression, right? If you want to get the inverse function, to choose the correct one, usually we will look at the domain, okay, to decide whether you want to accept the positive square root or negative square root. But now the problem is when we are having the plus and minus sign, if you look at the domain given here, the value for domain also have negative to positive value. All right, so it is quite hard for us to decide from here. Okay, so to decide the correct inverse function, what I did is like I try to recall back some basic formula, some basic graph. So as an example, if let's say if I want to sketch y equals to x power 3, the graph will look something like this. And if I want to have y equals to negative x power 3, then the graph will look something like this. So this is how I try to link. All right, when I'm having a positive x power 3, my graph looks something like this, and you can see that the function or the graph, right, mainly is in the first quadrant and also the third quadrant, right? Then when we are having a negative value in front of the x power 3, so you can see that they are reflected, okay, through the x-axis, and therefore your graph appear here, which is in the second quadrant and also the fourth quadrant. Okay, so I try to link it with our first part. So for the first part here, generally you can see that our graph mainly is in the second and also the fourth quadrant. And this actually match with the original function. So you can see the original function, we're having a negative sign in front of the function. And that's why our graph is in mainly second quadrant and fourth quadrant. The same thing happened for this one. So our inverse function is also in the second quadrant and the fourth quadrant. Therefore, for me to select the correct inverse function, I will choose the negative function, which is negative 2x divided by square root 1 plus x squared. Okay, so this is how we actually choose the correct inverse function for this question. Okay, all right, then now we proceed to part number C. All right, so for part number C, okay, they mentioned that the function g is defined by this, and also a is a constant. All right, so they want us to state the maximum possible value for a, for which fg can be formed. Okay, so fg is the composite function. All right, so for a composite function, generally we are having some, you can express it by using the diagram, arrow diagram. All right, okay, so from here we should know that the first, okay, come with the function g followed by function f. Okay, and that's why this whole function completely will be fg, composite function fg. Okay, so if I look at the first circle here, the first diagram here, it is actually the domain of g because the g starts from here. For the second circle, it will be the range of g. At the same time, for this second circle, it is where the function f starts. Therefore, it will be domain of f as well. And until this part, it will be the range of f. Okay, so from this diagram, generally, we can actually observe one important result where the range of g, okay, so yeah, the range of g will be actually equals to the domain of f. Okay, all right. Then now, how can we continue to find out the value of a? Okay, so to get the range of g, we know that gx is equals to 2x. And it is given that the domain is from negative a to positive a. So if let's say I'm having 2x here, it will become 2a to negative 2a. And this 2x is actually your gx. So from here, you will know that the range of g will be from negative 2a until positive 2a. Okay, so for the range of g, I will write it out as negative 2a, then gx, and then 2a. All right. How about the domain of f? Okay, so for the domain of f, you can refer back to the previous question here. They actually show us that the domain of f is this one, negative 2 until positive 2. Okay, so for the domain of f, I'm having negative 2 until positive 2. And now I actually want to compare these two equations, these two inequality lah. Alright, so to compare these two inequality, generally they should be equal to each other lah. Regardless the gx and also the x, the value here should be the same. So negative 2a should be equals to negative 2, 2a should be equals to 2. So from here you can see that 2a is equals to 2 and therefore a will be equals to 1. Right, so this is how I actually prove, I actually show how I get the value of a. All right, so there might be some other better method, okay, but this is what I can show for now. All right, okay, then now we continue to part number D. All right, so for part number D, they want us to find out the composite function for f g x. All right, so the function for f g x will be f and then gx. That means first I need to substitute function gx first, which is 2x actually. And after that, I substitute the 2x into the function f. So negative x become negative 2x over square root 4 minus x squared will become 4 minus 2x squared. And then from here, I try to expand the square. I will have 4 minus 4x squared. Then if I continue further, I want to simplify it, try to simplify it. So from here, I realize that I can take out the 4. And if I take the square root 4, I will have 2. Then I can simplify this. And eventually I will get, sorry, there's no more 2, right? So eventually I will have negative x over square root 1 minus x squared. Alright, so this is the composite function that I have for now. Okay, so and now we come to question number 7. Right, so they want us to show that this equation can be expressed like this. Okay, alright, so you can see that for the original equation that we are having here, generally you have tangent and cos, and our final answer that want to show there's no more tangent and cos, but everything becomes sine. Okay, so let us start from the equation given first. So we are having tangent x plus cos x divided by tangent x minus cos x equals to k. So for the first step, I will want to move the denominator to the right hand side. And at the same time, I will want to use the identity for tangent, which is equals to sine over cos. So I'm having sine over cos for tangent, then minus cos. Alright, so again, I don't want to have any denominator in my solution here. So for all the cos x, I will want to make it disappear. So to make it disappear, the whole equation, this whole equation, I need to multiply it with cos x. And therefore, this is what we have, cos square x, sine x, cos square x. Okay, and after that, for the next step, because my final answer, there's no cos square. Everything is about sine square, which means that I need to apply the other identity where cos square plus sine square equals to 1. So cos square is 1 minus sine square. The same thing happened for the right hand side. So I'm having negative 1 minus sine square. Okay, so from here I can slowly simplify the whole everything here. Okay, so if I didn't do any careless mistake, then I will move all the thing to one side first. And factorize them. So I think very obvious, this is actually the equation that they want us to prove. Right? Okay, then now continue to part number B. Okay, so for part number B, they are saying that hence solve the equation, okay, tangent x plus cos x divided by tangent x minus cos x equals to 4. Okay, so if you compare the value, when they are mentioned that this is equals to k, and now they want to solve it for 4, okay, which means that k is equals to 4. And I will want to, when I want to solve this equation, right, I will need to substitute k equals to 4 into this quadratic form equation in terms of sign, so that I can solve the equation. All right, because you already proved in part number 1, saying that this equation can be rephrased like this. Okay, and now you just let the k equals to 4 and substitute into this equation to solve it. All right, so when I substitute k equals to 4 into the equation, I'm having 5. So 5 sine square x plus 3 sine x, then minus 5, and it is equals to 0. Okay, so if you try to factorize it, you will realize that you're not able to factorize nicely. So you need to use a quadratic formula to solve it. So it will be 3 squared minus 4ac, then divided by 2a. Okay, and then what we have is plus minus square root 109 divided by 10. Okay, so from here, sine x will give you two different values. So sine x equals to 0. A long value will be 744,0306509. Another one will be sine x equals to negative 1.34403. Okay, and of course, we need to ignore this one, because if you try to take the cos inverse value, you'll get a math error. Okay, all right, so we will focus to solve only this part. All right, so to get the answer for x, I need to have a basic angle first. So by pressing sine inverse, the basic angle that I get for this part is 48.1. All right, and we are looking for the value of x. So for the value of x, they are looking for 0 until 360 degrees, which means that from quadrant number 1 until quadrant number 4, you need to go for one round. Okay, then now we refer to the function here, sine positive. So in which quadrant sine will be positive? Okay, so first quadrant sine will be positive. So the answer in first quadrant will be the basic angle, 48.1. Then sine will be also positive in the second quadrant. So to get the answer for second quadrant will be 180 minus the basic angle. So it will be 131.9. So this will be actually the two answers for the x. All right, so now we are having question number 8. Okay, so the diagram shows the curve. There are two curves here actually. All right, so this is the first equation and this is the second equation, second curve. The curve intersect at the point A and B. All right, so they already give you the points here, and now they want us to find the area of the region between the two curves. All right, so the region between the two curves actually means that this is the area that we are interested in. All right, so to find the area between the two curves, right, generally we need to know, and we actually can see also the area covered is actually from this point where x is equals to 1/4 until this part, which is actually x equals to 4. So that means the x equals to 1/4 and also the 4 will be the limit, okay, for our integration later. All right, okay, so let us start to find out the area. It will be actually equals to, we need to integrate from 1/4 until the limit 4. And what is the function on top? So this is the function on top, where it will be 5/2 minus x power half. And then we need to minus the area covered by the bottom curve. All right, so the bottom curve will be actually minus x negative half. All right, so to get the answer for the integration, for the area, we need to integrate this function. All right, so which means it is actually the curve on top minus the curve at the bottom. Then the limit will be the intersection points between the two curves. All right, so when we do the integration, generally we are having 5/x. The power plus 1 becomes 3/2, and then divided by 3/2 as well. Then this time I'm having 1/2, then divided by the new power 1/2. And you need to put in the limit of 4 and 1/4. Okay, So if you try to rephrase it, what we have is like I'm having 5 over 2x, then minus 2x power 3 over 2 over 3, then minus 2x power half. And now I substitute the value 4 into the equation, into the expression. So when I substitute 4, I'm having 20 over 2 minus 16 over 3 minus 4. Then if I substitute 1 over 4 into the equation or expression, then I will have 5 over 8 for the first term, minus 2 over 24 for the second term, and also minus 1 for the third term. Alright, so if let's say we didn't do any careless mistake, then the area will be 9 over 8. Okay, so this is how we get the area by using the integration technique, right? Okay, then now we continue to part number B. So what they want us to calculate for part number B? So for part number B, they are saying that the normal to the curve at point 11 intersect the y-axis at this point. So find the value of P. Okay, so first we will focus on the normal to the curve first. And this line intersect the y-axis. So to find out the 0p, to find the p, right? Generally, what we need to do is that we have to form the normal equation, okay, to the curve. So to find the normal equation, we need to find out the gradient of tangent first. So to find the gradient of tangent, you need to find out dy dx. So you put a power in front, power minus 1 become negative 3 over 2. And we try to substitute the point because the normal equation is at point 11. So you substitute x equals to 1. So when we substitute x equals to 1, you are having the negative half. Alright, so please take note that this negative half is actually the gradient of tangent. And we are interested in gradient of normal, right? Okay, so the gradient of normal is perpendicular to gradient of tangent. So gradient of normal multiplied with gradient of tangent, you will get negative 1. And from here, you will know that the gradient of normal will be actually equals to 2. Okay, then now we will form the equation of normal. So I need a gradient. Gradient you already have that for the normal and also the passing point. So the normal line pass through the point 11. So the equation will be y minus 1 equals to 2x minus 1. So if I continue from here, I will get y equals to 2x minus 1. Okay, then we are interested to find out the point that intersect the y-axis. So intersect y-axis means what? Means that your x is equals to 0. So substitute x equals to 0, you will get y equals to 1. Oh, sorry, equals to negative 1. And this also means that the value of p is actually equals to negative 1. Alright, so now let us discuss question number 9. So the question number 9 is about the line y equals to 2x plus 5 intersect. Okay, so they already mentioned that they intersect the circle with this equation. And this is a circle equation at A and B. They want us to find the coordinates of A and B in surd form. Alright, so surd form. And after that, they want us to find the exact length of the chord AB. Alright, so generally, they want us to find the intersection point because A and B are intersection point. Alright, so I will let y equals to 2x plus 5 as the first equation. And we want to find out intersection point. We need to substitute into the second equation, right? The curve equation. Okay, so I will substitute equation number 1 into equation number 2. Alright, so I will have x squared plus 2x plus 5 squared equals to 20. Sorry, I made a careless mistake here. It should be a 20 here. Alright, and next I will try to expand it. And then if I try to rephrase everything nicely, then I will have 5x squared plus 20x plus 5 equals to 0. And I can further simplify it, become x squared plus 4x plus 1 equals to 0. Okay, so here we get a quadratic equation, and you will realize that we're not able to factorize this quadratic equation. So to solve for the x, we need to apply the quadratic formula, which is negative b plus minus b squared. So b squared minus 4ac divided by 2a. Alright, then we will have square root 12 divided by 2. Then we can further simplify it as 2 square root 3 divided by 2. And hence, after you simplify, you have negative 2 plus square root 3. Another value will be negative 2 minus square root 3. So this is the x coordinate for A and also B in third form. Alright, and after that, I want to find the y coordinate. So when x is equals to negative 2 plus square root 3, right? You substitute the value of x into this linear equation. So you will get the value for y, which is equals to 1 plus 2 square root 3. And then when x is equals to negative 2 minus square root 3, from here you will get the y, which is equals to 1 minus 2 square root 3. So maybe for us, we already find out the coordinate for A and also for B in the third form. Alright, so this is the first part of the answer, A and also B. So I think if you exchange the coordinate, also no problem, because they didn't mention what is the coordinate for A and B. So it can be anything, okay? It can be A here, B here, also no problem. And after that, they want us to find out the exact length of the chord AB. So to find out the length of the chord AB, we'll use the formula x1 minus x2 squared, then plus y1 minus y2 squared. So my x1 now is negative 2 plus square root 3 minus negative 2 minus square root 3. So x1 minus x2, then you square it, plus y1 minus y2. So y1 is 1 plus 2 square root 3 minus y2 is 1 minus 2 square root 3. And then I square it also. Okay, so before I expand the whole thing, what I need to do is that I try to simplify the thing inside the square. So I try to simplify all this value here. I'll get an easier value, which is 2 square root 3 square plus 4 square root 3 square. Okay, so simplify first before you expand everything. Then after that, we are having 12 plus 48. And therefore, you can write it become square root 60. Or you can further simplify, become 2 square root 15. So this is actually the length of AB in the third form, or the exact length. So when you see the word exact length, means that you have to rephrase the answer in terms of maybe third form or maybe pi and so on. Alright, so this is what we have for part A. And now we continue to part number B. So there's a straight line through the point with the gradient m. Is a tangent to the circle. Okay, so they want us to find the two possible value of m. Okay, so now we focus on this straight line first. Okay, so this straight line is a tangent to the circle. So the tangent means what? Means that intersect at one point with the circle. Okay, so generally this is what this is the idea, right? Okay, so first I think we should try to form the equation of the straight line first. Okay, so the equation of the straight line, it will be y minus y1, which is 0, equals to m, gradient is m, and then x minus x1, so minus 10. And my first equation will be y equals to mx minus 10m, my first equation. And because of, I know that they are talking about intersection, right? Intersect at one point, so they are still talking about intersection. Therefore, what I do is like, I want to substitute this line equation into the circle equation, like what we did just now in part A. Okay, but now we have to substitute y equals to mx minus 10m. Okay, so I want to substitute it into the circle equation. So x squared plus y squared. So it will become mx minus 10m, this is y, and then squared, equals to 20. Okay, then we do the same thing. Actually, we expand everything. Okay, so after I expand everything, I will have something like this. And now, of course, I want to try to simplify. Okay, so for x squared, I'm having m squared plus 1 x squared. Okay, then for x, I'm having negative 20 m squared and then x. Then the third term, the constant term will be 100 m squared minus 20, and it is equals to 0. So from here, very obvious also, you can see that it is actually a quadratic equation. Okay, x squared and then x and then a constant term. Okay, and then how are we going to find out the value for m? Okay, the keyword is tangent, because we already know that tangent means the line intersect at one point with the circle, which means that we can use the result of b squared minus 4ac equals to 0. So equals to 0 because of there's only one point intersection. 2-point intersection, it will be b squared minus 4ac greater than 0. Alright, so we can use the result b squared minus 4ac equals to 0. So my b squared will be negative 20 m squared, then square, minus 4ac. And it is equals to 0. Alright, so if you try to expand everything in detail and you didn't do any careless mistake, right, you will have 320 m squared equals to 80. And from here, m squared is equals to 1 over 4. And therefore, the m will be plus minus 1 over 2. So these are the possible values for the m that we have for this equation, for this question. Okay, so we have come to the very last question, question number 10. So they give us equation y equals to fx and the f prime x. So this is the f prime x where k is a constant. So k is a number actually. So the curve has a minimum point at x equals to 2. Okay, so minimum point, then x equals to 2. Okay, so for the first part, they want us to find the second derivative of the function f prime prime x in terms of k and x. Then after that, they want us to find something. So maybe I focus on the first part first. Okay, find out the f prime prime x. So f prime x is already this one, 1 over 2x plus k power negative 2 minus 1 plus k power negative 2. So when I want to do the differentiation, okay, so for the bracket with x, I pull the power in front, copy the bracket, power minus 1. And after that, I need to differentiate the thing inside this bracket and multiply it. So it will be equals to half. Okay, then for the second term here, 1 plus k is actually a number, just like maybe 3 or 4 or whatsoever. So when you're having 4 power negative 2 or 5 power negative 2, right? Any power, or sorry, any number, when you want to differentiate it, you will get a 0. So this whole term at the end will be, at the back will be 0. Alright, so my f prime x will be something like this, and I wish to further simplify it. Okay, so if I further simplify it, then it will look like negative, then 1 over 2x plus k power negative 3. Okay, so this is my f prime prime x in terms of x and k. So we're done for the first part. Second part, they want us to find the set of possible values of k. Okay, so to find the possible value of k, right? When we talk about the maximum point, minimum point in differentiation, okay, the how we use or where we use the f prime prime x. We will use the f prime prime x to decide whether is it minimum point or maximum point, right? Okay, so for this question, they already give us important info where the point is minimum point. So when we are having a minimum point, it means that your f prime prime x is actually greater than 0. It is a positive value, therefore only you will get a minimum point, right? Okay, so for this f prime prime x, the value of x, you need to substitute it by 2 because at x equals to 2, the particular point is a minimum point. Okay, so I will substitute the value here. Then I will have negative. Substitute x equals to 2. So you have 1 plus k power negative 3 greater than 0. And if I move the negative over, I will have it smaller than 0 because when you move the negative value over or multiply a negative value or multiply or divide a negative value, you need to change the inequality sign. Okay, so this is what we have here. And what is the value of k? So we need to do some small analysis here. Smaller equals to 0 means that it is a negative value. Correct or not? So they want us to have this term to become a negative value. So this is positive. So a positive value need to divide a negative value so that overall will be a negative value. So after this step, I can write like this. So 1 plus k power 3 should be a negative value which is smaller than 0. So k will be smaller than negative 1. So this is the set of the possible values of k. Okay, right. Then now we proceed further to part number 2. Okay, so for question number 2, they tell us that the k is equals to negative 3 now, and the minimum point is this one. So they want us to find the fx. Okay, so to find the fx, we can start from the f prime x. Okay, so I rewrite again because we already know that the k is equals to negative 3. So my f prime x equation will look something like this. It will become half x minus 3 power negative 2, then minus negative 2 power negative 2. So if you try to simplify again, then you will have this. Okay, all right. So to get the function f from f prime x, of course, we need to do the integration. Okay, so we need to integrate the function f prime x. And when we do the integration, copy the power, we copy the bracket power minus 1. So divided by the new power, divided by the differentiation in the original bracket, which is half. Then minus 1 over 4x plus c. Okay, all right. Then of course, continue to simplify further so that it looks better. It looks nicer, right? So you're having negative 2 over half x minus 3, negative 1 over 4x plus c. Okay, so this is my function fx, and I actually need to find out the value of c. So to find the value of c, we need the information about the x and y, which is this point. Okay, so here this point is actually lies on the curve, right? So you can substitute this point to get the value for c. Okay, so it will be y equals to, maybe I write it out first at this point. Okay, so 7 over 2 will be equals to negative 2 over negative 2 minus 1 over 2, then plus c. Okay, so from here I'll get c equals to 3, where I need to rewrite again the original function that we get. It will be negative 2 over half x minus 3, then minus 1 over 4x plus 3. So this is my complete function, okay, with the value of c equals to 3. So this is what we have for part number B. Alright, then now we continue to part number C. Okay, so for part C, they want us to find the coordinates of the other stationary point and also determine the nature. Right, so to find out another stationary point, we need to let f prime x equals to 0. So when f prime x equals to 0, it means that we are having 1 over x minus 3 power negative 2 minus 1 over 4. It is equals to 0. Alright. Then next, we will have 1 over half x minus 3 square equals to 1 over 4. And after that, I take square root. Or maybe I can rewrite again as I'm having half x minus 3 square equals to 4. So half x minus 3 equals to plus minus 2. Okay, so from here, I will have two answers. The first one will be half x minus 3 equals to 2. Another answer will be half x minus 3 equals to negative 2. Okay, so if you continue further, then you can see that this will give you value x equals to 10, and this one will give you the value of x equals to 2. So you already know that x equals to 2 is the minimum point for this curve. Alright, so we are actually more interested in this x equals to 10. Okay, so again, when x equals to 10, I need to find out the value for y. So y will be equals to, substitute your y into the original equation, or x equals to 10 into the original equation here. Okay, we have negative 1 minus 10 over 4 plus 3, and your y is actually equals to negative half. Okay, alright, so you have the x coordinate and y coordinate already. Now we want to decide whether is it a maximum point or minimum point. So this is my f prime x. I rewrite it again for the k equals to negative 3. And of course, I need to substitute the value of x. So for this point, x is 10. And you'll get negative 1 over 8, which is smaller than 0. So from here, you can actually make the conclusion saying that we have a point here, 10 and negative half. It is actually a maximum point. Alright, so this is how we actually complete this question number 10. Okay, so thank you very much for watching this video. Bye bye.